Welcome to this module of Professor Messer's free CompTIA A+ certification training course on network topologies. I'm James Messer, and in this module, we're going to discuss the requirements from CompTIA Exam 220-601, Section 5.1, where we're going to need to learn more about the names, purposes, and characteristics of technologies for establishing connectivity. And the 220-602 exam expects you to go into a little bit more detail than the 601 exam does. In this module, we're going to talk all about different topologies. We're going to talk about Ethernet, WAN, and token ring. We're going to talk about a lot of different kinds of networking types, which are a little bit different than topologies. We'll then go into an understanding of how wired networks are connected and wireless networks, different topologies, different technologies, and different connectivity types. Let's start with understanding more about topologies. Different types of networks are configured and connected in different ways. Whenever we see one of these style of graphs, this is a description of how data transmits between devices on these different topology styles. One very early type of topology style was called a bus topology. These were used in very early local area networks, and this was very simply a cable that you would drape across the floor, and then devices would plug directly into that cable. It's very simple, but the problem is that it was prone to errors. If you had a break in the cable on one side, it completely disrupted communication for the entire length of that cable. So bus topology isn't used much in that form any longer, but it's still a valid networking type, and occasionally you will run across a bus style network in the way that it works. These days, a more common networking style or topology is a star topology. Now, this picture is really describing also the way data flows across a star topology. You usually have a central device, and that central device is what everybody talks through. Now, looking at that, you'd think that that might be very difficult and certainly less efficient than some of the other topology styles that you might be able to see. But in reality, having that central device in the middle allows you with a lot of capabilities, especially now these days with our technologies that allow us to move a lot of data very quickly. So what you're going to find, even if it's a very small network all the way up to your largest networks, they are probably running with a star topology on the largest part of their network. The central device and where it is on this network becomes critical, obviously. And in most networks, there are multiple devices in the middle that allow redundancy to occur. So although we've got a very simple picture here, this is just how the data flows. This is not the actual physical device configuration. Normally, the configuration of the devices on the network is much more advanced and much more complex than what we have here in this diagram. But this does show how the data flows. And when you describe a star topology, or you are expected to understand how a star topology works, this is a very accurate description of that. One of the most common star topology type networks out there is one called Ethernet. And Ethernet is one of the most popular networking technologies in the world. You will see it in the small organizations, large organizations, on every country you'll go to that has a network. This uses a standard from the IEEE called IEEE 802.3. You don't often see it referred to in that way. Most everybody says that's an Ethernet standard, but that is what they were referring to. If you look at the fine print on the box that you get for your cable modem, for your router, for your Ethernet cards, you'll see somewhere on there it says this is an 802.3 standard device. The idea is that you have to make sure that devices on both sides of the connection are using this standard to be able to communicate to this network topology of Ethernet. There are many different cable standards for Ethernet, but usually these days, whenever you see an Ethernet network, it's an unshielded twisted pair network. And that's what we're going to see whether you walk into some of the largest organizations in the world, or if you just bought a router for your home, it usually has in it a UTP cable. Now, you'll see if you move ever to older organizations, or you see some legacy networks that are out there, they may still have coaxial network connections between them. You don't often see those anymore, but Ethernet's been around for so long that the cabling types through the years have changed. So you have to keep up with the changes, but just know that most of the time these days, the networks that you'll run into for Ethernet are UTP connections. Today, you'll find Ethernet speeds running anywhere from 10 megabit per second all the way up to 10 gigabit per second and beyond. Most common Ethernet networks these days are either running at 100 megabits per second or at 1 gigabits per second. You'll find most of consumer products anyway, the Ethernet cards will run at a maximum of a gigabit per second. You just have to make sure that if you're plugging in multiple devices to perhaps a centralized switch or a centralized router, that you're going to want to plug them in at speeds that both sides will be able to negotiate at. So if you have a gigabit connected Ethernet on your laptop and you plug it into a 100 megabit connection, your laptop will probably move down to the slower speed so that both of you can communicate properly. So if you want the fastest possible speed out of your Ethernet connections, you're going to want to make sure that devices on both sides of those links can support those higher speeds. Here's some common Ethernet type devices. One that you see on the left is something very common if you walk into the data center of a very large organization where you're plugging in hundreds and hundreds and hundreds of different devices, whether they are copper type devices or down here at the bottom are these fiber connections on this particular Ethernet switch. So these devices are really designed for very large enterprises where you're plugging in hundreds of people and devices. In your home office, you may have something like a wireless access point with a router built into it, where you plug one connection into your internet connection and the other Ethernet connections that are on there plug into devices you might have in your office, or it may be a wireless connection where you're not actually plugging in through a wired Ethernet. Either way, it's exactly the same cabling, it's exactly the same protocols, it's exactly the same configuration, the same IEEE standard to be able to connect these devices together. It's just that one's designed for large organizations and one's designed for very small organizations. Another topology style that you'll see out there is something called a ring topology. This is used in many popular topologies through the years, although from a local area network perspective, we don't see many ring technologies being used that way anymore. However, on the wide area network side, on a metropolitan area network, we still see this technology used quite a bit, because what you'll do in a very large area, perhaps around a large municipality, you'll connect devices up and then you'll have a separate line between them as well. So that's really two wires between each one of these. That way, if you lose one pair, the ring can also go the other direction. So there's redundancy built into it. This is a very common to see on the MAN and WAN, but you don't see it very much on the enterprises because most everybody's moved to an Ethernet type connection, and it's using that centralized switch in a star type mode to be able to do that. But people still have some legacy token ring connections out there. Token ring is a legacy network style that's seen on these networks. It's one that still is very popular in many environments because you can still buy a lot of token ring technology out on eBay. There are still drivers in Windows that will support token ring connected devices. This uses a different standard from the IEEE called 802.5. The 802.5 group, they're not really in use anymore. They're not even meeting anymore to create more standards of token ring technology, but you still see some shielded twisted pair and even unshielded twisted pair, the same cable that you would use for Ethernet. Ultimately, you were also able to use for token ring. Token ring ran at much slower speeds though, 4 megabit or 16 megabits per second. So you can see that is a little bit outdated compared to the speeds that you get with Ethernet. There were some standards created for 100 megabit per second token ring and 1 gigabit token ring, but unfortunately, no products were ever created for those. It's a standard without anything that you could ever apply towards it. So the best you're ever able to get these days out of token ring is 16 megabit per second, and it's very difficult to find any new products. There are no more manufacturers really creating token ring technology any longer. There are a number of networking technologies that go across large distances, wide area networks, and generally it's a third party that does this for you. It's a carrier that provides a cloud for you. You purchase this technology, and that carrier brings in their link into your building and gives you a jack and says, here's where you plug in your network on this side. I'll go connect up your other link in Walla Walla, Washington, and you can connect to the network on that side. I'll take care of everything in the middle. You don't even have to worry about it. And because we really don't know what's in the middle of this network, we call it a cloud. And that's a very good way to say if we have any problem communicating to or from the cloud, we just call our carrier and say we're having an issue with that. It's up to them to resolve the link. Many legacy WAN technologies you'll hear referred to as a T1 or a T3. These are also referred to as a DS1 or DS3. The names generally are interchangeable. They are a little bit different in their underlying technologies and how we're referring to them. But if somebody says, I have a T1 connection, a T3 connection, that's what they're referring to. These days, many of the modern wide area network topologies are things like frame relay, or even more modern, something called MPLS, a multi-protocol label switching. The new MPLS networks are really very widespread because they're very inexpensive relative to some of the other technologies that are out there, and they allow companies to do some specialization of their of the topology protocols going across the network. Companies are able to put both their voice and their data over the same link and prioritize that data a little bit better. So MPLS is becoming very popular. Now that we've built the fundamental technology that's going to run the network, our topologies out there, we also need to understand that there are different ways that these different devices use to communicate. So there's different networking types that are used. The very common one is called client server. This is where many different devices communicate to a central server. This is used very often on web servers. So if you're looking at my video on the internet right now, there may be other people watching this same video at the same time. And they're doing that because the technology and the style of networking that we have here is one that allows multiple people to communicate back to that central server and be able to pull data in different ways from it, in some cases simultaneously. You also see this a lot on database servers. If there are many people out in an organization and they all need to access the same chunk of data, then they can all access that centralized server or set of servers through a client server type technology. There's also a style of networking called peer-to-peer. Peer-to-peer networking means that one station talks to another station, and they have a single connection between them, and they're communicating without any third party in between. It's one station talking one-to-one with another device. These days, we see this a lot with file transfers and peer-to-peer technologies, being able to look for somebody who has a file and then simply going to that one device to pull that file down. If we want to get another file, we may have to break that connection and go to another device through a peer-to-peer connection to get the second file. So we don't often see this with web servers or database servers where everything's centralized. Peer-to-peer networks tend to be very decentralized in the way that they work. So let's think about this. If we were going to have a client-server network or peer-to-peer network, and we wanted to use instant messaging, what style of networking does instant messaging use? Instant messaging actually uses both of these. The way that instant messaging works is that it connects first to a centralized database of systems. So everybody, when you log into your instant messaging, everybody's now listed in a major list, an important list of where everybody is logged in on the network. And so you'll see a big list of those devices and you'll see, oh, my friend is logged on right now. Let me communicate with them via instant messaging. I'll send them a quick note. And as you type that in and hit enter, what you've done is now take the information you gathered from the centralized server via client server, and you've now got their local IP address that you can now communicate with them directly over peer-to-peer. So it's not, this is a very interesting scenario because many applications work this way where they will start out client server, but they may change their communication type to be direct to another machine. So you do have to look into how applications are performing as to what networking type they're using, but you should probably be familiar with these different technologies and the different ways they work because they're going to come up on the A+ exam. A huge part of the A+ exam focuses on the way that Microsoft devices network. And there's a couple of different ways that Microsoft devices can network. One is called using workgroups. Workgroups in Microsoft terminology is a grouping of local devices. So if you're in a very small business, you're working at home, you have a home network, normally you would put all of your home network devices on the same work group. There's really no global management of these work groups. There's no way to say change the password for a single user and have it affect every single machine in your environment. There's also no centralized authentication. When you log into one person's machine, it may be a completely different login to someone else's machine, and you may have no login to a third machine on your work group. There's no single login into all of those devices all at once. So this really is designed for something like a small office. In larger environments, you see something called Microsoft domains. Domains are very, very structured in the way that they work. And generally, there is a domain administrator that initially configures and maintains this domain network. But it also provides you with a way to centrally authenticate into the network. When you walk into the office, you put in your username and password, and now suddenly you have access to any resource that you need on the network. If you need to print to a printer, you're already authenticated. If you need to connect to a network share, you're already authenticated into those shares. So it's very seamless, and it's also very easy to manage because you only need to change your username and password in one place. Ideally, you do see this in some medium-sized organizations and certainly very large organizations. Otherwise, you just have no other way to manage those. This is Microsoft-centric. Not everybody uses this style to be able to network these pieces, but some of the underlying technologies and the way that they work is copied no matter what type of technology you're going to go to. But as we go through A+, keep in mind the Microsoft Workgroups and the Microsoft domains and the differences between them. Just because you're working in a wired network environment doesn't necessarily mean they're all using the same type of networking infrastructure or even the same type of technologies. For most LANs and WANs, you'll see this in whether it's a small organization or a large organization. And generally with bandwidths that are a megabit and higher, you'll see technologies like this. You'll see your Ethernet type connectivity or your token ring type connectivity. Those are higher speed local area networks, and they'll use something like some centralized switch, maybe a centralized router. If you're in a home office, it's your home office router access point that you use, but the technology is the same. It is this wide area network using Ethernet generally to be able to do that. In some older style wide area network connections, you have something like ISDN. ISDN stands for Integrated Services Digital Network. And before there was a DSL, almost everybody was using something like ISDN. This is a small office, home office ISDN router that plugged into your ISDN network here, and it had all your Ethernet connections off to the side. So I can plug in multiple devices to use that ISDN network. If I'm looking at more higher speeds these days, then I am looking at a DSL type network or a cable modem type network. This is a cable modem that you might use in your environment. This is the back of the device. You also have satellite networks you can use these days that will use the satellite to communicate down to you. If you're in a remote area that doesn't have DSL and doesn't have cable modem, that might be a viable option for you. These types of connections are generally 256 kilobits and higher. So we start at very smaller speeds, but these days even the cable networks are getting up into the 20 megabit per second and higher. In many corporate networks, they're using these types of technologies as a backup connection. They might have a higher speed MPLS network connection going in and out of their network, but at a remote site, it may be very critical that if that connection ever goes down, they use this little bit slower, but still a very practical network connection as a backup. In some very remote sites, if it's a small store or a small remote location, this may be the primary connection. So even in your enterprise environment, you may still be working with DSL and cable and satellite connections on a day-to-day basis. On many networks, there is still dial-up connections using modems, and this is just using the traditional telephone line, which means there's nothing extra fancy you have to have ready. You just have to have dial tone. And as long as you can plug in your phone line to your modem, you can run it a maximum of 56 kilobits per second. It's a very reliable way to communicate. It's using an infrastructure that almost everybody has. And if all you need is some simple set up your connection and let it run at very low speeds, this is still a very viable way to do it. In many network connections, this is sometimes the only way you have because you don't have a DSL, you don't have a cable, you don't have satellite. All you have is a phone line, and that's all you got. This is a great way to network. There are a lot of different options for wireless type network connectivity, but some of the more common are things like 802.11a, B, G, and N. And they all use a little bit different styles and technologies to be able to communicate at these speeds, but you can see the differences. 802.11a and B came out at about the same time. A was nice that it ran at 54 megabit, but the reason it didn't catch on was because it used a much higher type of frequency and therefore couldn't go quite as far, couldn't go through a lot of walls that we happen to have at our home environments, for instance. And that's why 802.11b became so popular popular at the home and the consumer market and really drove the demand to use that in more of a commercial type use. The newer technologies are 802.11g and 802.11n. The G is usually the one that you see most widespread because N is really one that's just now starting to become very, very prevalent. And indeed, there are some pieces of the 802.11n networking technology that are still being worked on. So it's not completely baked yet. But look at the speeds you get from this, even up to, practically speaking, about 100 megabit per second on your 802.11n type networks. So the wireless technology is really growing, really expanding, and one that's become a lot more prevalent and certainly become a lot more popular in the future. Another type of wireless networking that we see is something called infrared networking. You see this a lot between laptop devices or other types of cameras, for instance, and printers. And this is something that was created by the Infrared Data Association. So you may see it referred to as IRDA. It's a great way to network. It's very easy. It uses a line of sight so that it can communicate via infrared from one device to another. And in this way, we don't need any wires. We don't need to unplug anything to be able to print out something from our camera. We just hit a print button on our camera and suddenly we have things coming out on our printer. As long as both sides use that IRDA standard, we should be pretty good for that kind of wireless network. A very popular style of networking these days is something called Bluetooth, and this is referred to as a personal area network, and that's because the distances allowed for Bluetooth aren't very long. You can't walk too far away from your Bluetooth devices because they just don't put out enough power and are able to transfer information over those longer distances. This never really caught on as a fully featured network, but it can operate this way. It's just that you have to have all of your devices very close to you on the desk to be able to network with them. So it's perfect to use for a keyboard, for a mouse, and as you've seen, it's certainly good for your mobile telephone headset because your phone is never too far away from you. Bluetooth has found a good place for those pieces, but some of the enhancements to Bluetooth that are coming through are going to allow much faster speeds over a little bit longer distances. So you're going to also see Bluetooth technologies improve as the years go by. Another type of wireless technology that is really becoming popular are these mobile type networks. You plug in a USB connection or a mini PCI connection into your laptop, and you can go almost anywhere and be on the internet. This is extremely popular if you're ever mobile, you need to travel, or you just want to be able to connect to a network wherever you happen to be without having to worry if you're near a hotspot or you're near an 802.11 connection. You plug this in and you're getting pretty good bandwidth. It's up to 3 megabits per second in some areas and higher as the different networks are improving. Obviously, these mobile or cellular network type connections are very dependent on what the providers have in that area and what they are supporting on the radio signals that they have going through the air. But just being connected in a place where you normally didn't have an internet connection allows you to do a lot of different things. And because a number of the applications these days are based on web browsers, this really expands your capabilities and what you can do over this wireless network. In review, we've looked at a lot of different networking styles and technologies. We've gone through client-server, peer-to-peer, and even our workgroup and domain type networks. Then we broke down both wired networks with our local networks, our wide area networks, our ISDN, and our high speed. And we looked at our wireless technologies with our 802.11, infrared, Bluetooth, and even our cellular and mobile type connections. For more CompTIA A+ videos, to participate in our message boards, or take advantage of any of our free resources, visit our website, freeaplus.com.